All right, today we're going to start section 4.2, which is going to be dealing with experiments. So it should have your notes in your note packet, so follow along as we go through this. So we're going to start but not finish the packet today. So we're going to start by looking at the difference between observational studies and experiments. You need to be able to determine if something is going to be observational or if it's going to be an experiment. So sample surveys, the things we've been looking at, are one kind of an observational study. So observational studies that examine existing data for a sample of individuals are called retrospective. So observational studies that's just looking at past stuff is what we're talking about here. Observational studies that track individuals into the future are called prospective, like what might happen if this goes on forever. So when we're looking at observational studies, we're going to look at some examples or some real life things as we talk through some of our definitions, which we have a lot of today. So the first one that we're going to look at here is taking a vitamin D supplement good for you? So there's been hundreds of observational studies have looked at that relationship between vitamin D and a person's blood and other various health outcomes that they have. So formal definition of our observational study would be that we are observing individuals and measure variables of interest. But the biggest thing is an observational study does not influence the response. You are just watching and seeing what happens and then tracking the responses. So when we have an observational, we still have a thing called a response variable, similar to what we had in chapter 3. Our response variable is going to measure the outcome of a study. What is it that we're looking for? An explanatory variable then would be, sorry, my phone was going off for a second. An explanatory variable may help or explain or predict the changes in the response variable. The same thing like what we just had in chapter 3. Unfortunately, it's difficult to show that taking vitamin D causes a lower risk of diabetes just using an observational study. Observational studies are not good for showing that something causes something to happen. Okay, so again, when we're taking still example that we've been looking at, it's a vitamin D supplement, good for you, and we have all this. So when we do this, they did an observation that's been done, and they looked at vitamin D concentrate as our explanatory variable. That's what's happening, and they looked at the quality of diet, the amount of exercise, all sorts of different variables in here along with it. They had two different groups, and a good diet, a better diet, more exercise, less exercise. They tried to compare things and, less likely to have diabetes or more likely to have diabetes by what's going on. But unfortunately, when we go through here, we had a lot of variables. And when that happens, we have something called confounding. So confounding is going to occur when two variables are associated in such a way that their effects on a response variable cannot be distinguished from each other. So, what caused less likely to have diabetes? Our better diet, or was it the more exercise? When we put it all together, then you don't necessarily know which one is causing it to happen or helping it happen. So confounding is when we can't tell the difference between those variables. Okay, so thinking about that, then to determine if taking vitamin D actually did cause a reduction in diabetes risk, people in Norway performed an experiment. So before we were looking at an observational study. The researchers randomly assigned 500 people with pre-diabetic diabetes to either a high dose of vitamin D or a placebo. We'll talk about placebo again, but that's just a pill that looked exactly like the vitamin D, but actually was just nothing. It's like a fake medicine. And then after 5 years, 40% of the people in each group were diagnosed with diabetes. So when we look at this, some things that we're talking about in here that we need to look at. An experiment deliberately imposes a treatment on individuals to measure their responses. Okay, so I'm deliberately imposing, I want to see if it causes something to happen. A placebo is a treatment that has no active ingredient, but is otherwise like other treatments. So usually it's like a sugar pill of some kind that looks like the medicine people are taking, but it's not actually the medicine they are taking. Okay, so an experiment is a statistical study, and when we are actually doing something, okay, we're doing a treatment to people, animals, objects, something. So when we do this, we have some more things that we need to look at. Experimental units. We want to observe what happens when we deliberately impose something on someone or something. So in here, when we do that, we have a specific condition applied to the individuals is a treatment. So maybe you're taking a low dose, you're taking 50 milligrams, you're taking 100 milligrams, you're taking a placebo, okay? We're doing a treatment of some kind. If an experiment has several explanatory variables, a treatment could be a combination of specific values of these. Okay, maybe you're taking medicine and on a good diet. Maybe you're taking medicine not on a good diet. So we look at different things that are happening. Within that, we have an experimental unit is the subject to which a treatment is randomly assigned. So units can be human beings, they can be dogs, they can be any kind of animal, there's all sorts they can be. But when they are human, we call them subjects, not an experimental unit. We call them subjects when that happens. Okay, so then when we look at this, the language, some things that we have to take into consideration. So we have, in an experiment, a factor is a variable that is manipulated and may cause a change in the response variable. The different values that we have for factors are called levels. Okay, so some different things. We've looked at lots of different vocabulary in here. So one of the things that you're going to be asked to do is, given a situation, we want to identify treatments. The experimental units, you may be asked to do more than just that, but those are some of the things that we're going to be doing. So here we have malaria causes hundreds of thousands of deaths each year, with many of the victims being children. We want to know if regular screening children for the malaria parasite and treating those who test positive reduce the children who develop the disease. So the researchers worked with children in 101 schools, randomly assigning half of the schools to receive regular screenings and follow-up treatments, and the remaining schools to receive no regular screenings. There was 101 schools were tested for malaria at the end of the study. We want the treatments and the experimental units. So experimental units is what we're looking at. So the experimental units were our schools, the children at the schools. Okay, we're looking at them, what was happening. And then our treatments, we had two different treatments because some schools were assigned half the schools. This is how we know that schools are units, because it's half the schools received regular screenings and follow-up treatments. So that's one. The remaining schools received no screening. So we had two different treatments that happened in there. Okay, so that would be our experimental units and our treatments. Here's another example. This time I want to list the factors and the number of levels for each factor, what we have. So here we have researchers, put the 5-second rule to the test. They used 4 different types of food. So we had 4 different types of food right here: watermelon, bread with butter, and gummy candy. They dropped the food into 4 different surfaces. We had steel, tile, wood, and carpet. They waited 4 different lengths of time, less than a second, 5 seconds, 30 seconds, and 300 seconds. And then they used bacteria prepared 2 different ways. So we had bacteria prepared 2 different ways. We had a soy broth or peptone buffer. Once the bacteria were ready, the researchers spread them out on the different surfaces and started dropping the food. Okay, so our factors are going to be all of these things that I underlined. Our factors are types of food, and then it wants to know how many. Well, we had 4 types of food. So there's our 4 types of food at 4 different levels. Our type of surface, we had 4 different surfaces. It may ask you to list them. In this case, it just said how many different ones did you have. We had 4 different time lengths, and then we had 2 different method of bacteria prep. So there's our example of listing factors and how many we have of each one. Okay, so you'll have some of your assignment will ask you to do that. So when we're designing experiments, there's several things that we'll look at. Good designs are essential for effective experiments, just as sampling was. So we don't want to start with, we don't want to have a bad experimental design. So let's look at a bad, just like we did bad sampling, a bad experimental design. We would take our units, we apply a treatment, and then we measure the response. Okay? In this design, there could be many variables besides our one treatment that we want to look at. Okay? Depends on what you're looking at, but just think taking caffeine can have different side effects on things. So we could have lots of confounding going on here. The remedy for a potential confounding is to do a comparative experiment with 2 or more groups. Okay, so when we do this, we have some options that we want to look at. Okay, so when we're designing experiments, we can have comparison. We need to make sure we have that. So in an experiment, we can have a control group is used to provide a baseline for comparing what our treatments are doing. Okay, that means this is what starts, what's going to happen afterwards. Depending on the purpose of our experiment, the control group may be given a placebo or they may be given nothing at all. It just kind of depends on what's happening. Okay, and in all other aspects, the treatment group should be treated exactly the same so that the only difference is the treatments. They may or may not know what treatment they are getting. This way, if there's convincing evidence of a difference in the average response, we can safely conclude it was caused by the treatments, not by something else. So when we're designing experiments, there's some things that we need to know here. So for example, the placebo effect. We talked about what a placebo was, but the placebo effect has a special name, and that describes the fact that some subjects will respond favorably to a treatment even if it's inactive. They just think they're taking something that's supposed to make them feel better, so automatically they are like, oh yes, okay, great, I feel better. Okay, a double-blind experiment. Neither the subject nor those who interact with them and measure the response variable know which treatment a subject received. Okay, so the person taking the medicine wouldn't know, and the person recording the information doesn't know what they were taking. That's double-blind. A single-blind experiment. Either the subjects don't know which treatment they're receiving, or the people who interact with them and measure the response variable don't know. Usually it is the person taking it doesn't know if it is a placebo or a medicine, hence the placebo effect that we are talking about up there. Okay, so to create equivalent groups at the beginning of experiment, we use what we call random assignment. We want random assignment to determine which experimental unit gets the treatment. So in an experiment, random assignment means that experimental units are assigned to treatments using a chance process. So chance process is kind of like a simple random sample because we're randomly assigning them. So maybe we use our number table the way we did to randomly assign patients or subjects to different groups, depending on what's happening. We also want to have a control. In an experiment, control means keeping other variables constant for all experimental units, except for the one that we're trying to show is causing something to happen. So after we randomly assign treatments and control our other variables, treatment groups should be about the same. Okay, the only thing that's different would be our treatments. Then a difference in the average response must be due to that treatment and not anything else that we were looking at. Okay, we can't say that any difference in average response between treatment groups must be caused by the treatments because there would likely be some difference just because of random assignment. It's unlikely to produce two groups that are exactly equivalent, but they could be very close if we do things enough that we would be able to say it. So with that in mind, being able to do it enough that we are able to see it, that's where our replication comes in. So in an experiment, replication means using enough experimental units to distinguish a difference in the effects of the treatments from chance variation due to the random assignment. So as long as we have enough replication, we can worry about it. Just as a little note right here, in stats, replication means enough subjects. In other fields, it has a different meaning, like doing the same thing over and over again. Replication means you use enough subjects or experimental units to show that something's happened, not performing the experiment over and over. So let's just look at a few examples here on designing experiments and talking about random assignment and answering some questions. So we have a total of 20 students have agreed to participate in an experiment comparing the effects of caffeinated cola and caffeine-free cola on pulse rates. Describe how you would randomly assign 10 students to each of the two treatments. So here's 3 different ways we're going to look at it. How would you do it? Using 20 identical slips of paper, using technology, or using Table D like we've done before. So let's just start with our how would we assign them using 20 identical slips of paper. So think about it. If we have 20 identical slips of paper, they all have a student's name on it, right? So on the 10 slips of paper, we would write letter A. There's different ways you could do this. This is one way. You could write letter A on 10 of them. On the other 10, write letter B. Shuffle the slips of paper and hand out 1 slip of paper to each volunteer. If they got an A, they're in the A group. The B, they're in the B group. You could put all their names on these sheets of paper and draw them out and The first 10 go into A group and first 10 go into B group. So there's multiple answers you could have had on that depending on what you did. Those are two different examples there. What about using technology? So here again, each student is going to have a number from 01 to 20. Randomly generate 10 different integers from 1 to 20. The students with these labels would receive the cola with caffeine, the remaining 10, the other cola, or vice versa, or something similar to that. Very similar to when we were picking a random sample. It's just that I'm picking one and they're going to one group, my leftovers are going into another group. If we were using table D, which is what we did a lot in our random sampling, again, we have to label each student with a different integer from 01 to 20, go to a line of table D and read two-digit groups moving from left to right. The first 10 different labels between 1 and 20 identify the 10 students who receive cola with caffeine. Notice I said 10 different because I can't repeat one. The remaining 10 students receive the caffeine-free cola. Again, ignoring groups of digits from 21 to 00 because we don't have any numbers that fit in here. This is a pretty good example to follow when I was telling you you had to write out paragraphs explaining how you would do something. This one hits a lot of the points that you would need in doing that and explaining what to do. So we are going to stop there for today. We will continue on next class. If you have questions, let me know. Your assignment is a worksheet that will be handed out to you. You can also find it on Canvas. Have a great day.